All right, so here's the problem. It's a truss problem. You can see from the problem statement that we just want 4 bar forces, and I've already put little squiggly lines in there to show you those. I guess we can just start off by noticing that, as we talked in class, that if you look at joint C, then what do you have? That's what we call our case 2 for our zero force member. So right away I can write down that the force in CG is 0. And if you want to be precise, you could say case 2, 0 force member. That would communicate to me that you've looked at it and you know from case 2 that that's correct. So there's one of them. That was pretty easy. So now let's imagine the structure because of these lines. Let's say it is cut down the middle, and we're looking at the left side or the right side. Which side would you prefer to work? Yeah, let's do a quick accounting. On the right side, I've got 1, 2, 3 applied forces. On the left side, I've got 2, so a little less to keep track of. If I do work the left side, I need to find my reaction. How many forces at the reaction? That's a roller. I don't know if you guys can see that. That's a roller, so that's just a vertical reaction. On the right-hand side is a pin. That's going to be a vertical and a horizontal. So it looks like the left side is the best way to go. So if I do work the left side, I just need this reaction. So the first thing I'm going to do is draw a free body diagram of the whole structure. And just to show you that I don't really care what's happening, I'm not even going to draw the internal members. Okay, I'm just going to draw this blob, or this solid, which is the truss. And I'm going to have a reaction at Y, I assume is up, another at E, an EX force, and that's it. And what I have applied, though, are a lot of forces. This is 500 pounds. All the other ones are in kips. So I'm just going to write that as half a kip. And then I would have 1 kip, another 1 kip, another 1 kip, and this other half kip over here. Now remember, all we really want is AY, so how should we find AY with one equation? Yeah, we can sum moments about E. So if I show you my sign convention, right-hand rule, and I sum moments about E and make sure I have an equilibrium. Does this half kip force create any moment about E? No. All the remaining forces, 1 kip, 1 kip, 1 kip, half kip, create what kind of moment? Positive or negative? Positive. Since all these have the same value, I'm going to pull that force out, and I'm just going to sum up their moment arms. So 12, 12, 12. So it'll be, the first one will be 12 feet, the second will be 24 feet, and the last one will be 36 feet. So that's the moment effect for these 3. And then I'll have the half kip, which has a moment arm of 48. And then I have AY, which creates negative moment, and its moment arm is 48. I think AY is going to be 2. But you guys should check that equation. Get 2?
Yes.
Excellent. How did I know it was 2? Although I look like an idiot savant, probably emphasis on the first word, I did not process this in my head. How did I solve that problem? Look at the loading. It's nice and symmetric, right? So I figured if you add it all up, half goes to one side, half goes to the other side. So I added all that up. It was 4. Half of 4 is 2. So if you see things like that, I would still encourage you to write the equation and check it, but that you kind of know what you should be getting. It doesn't always work out that way, but you take advantage of what information you have. Okay? Everybody good with that? Okay, so now I'm going to go back and draw my free body diagram for this left side that I wanted. So I'm going to quickly draw that. And this time I will include all the bars so you can see it. I have my reaction at AY, which I just calculated, which was 2 kips. At H, I have a 1 kip force. I have this half kip force at A. Just to give you some location, I'll go ahead and write in the node labels. So I'm going to assume that this is a tension force going from G to H, another tension force going from B to G, and another tension force going from B to C. Okay, trying to follow the same strategy that we applied on the previous problem, which you probably notice this is very similar to the previous problem in terms of its strategy. So let's try to write one equation and one unknown, and then not use that result in any other equations. So what would be a good place to start? Let's just think about summing moments about some point. What would be a good place to sum moments? B would be a good place because the line of action, where there's BC, BG, right, they won't create any moments. So I'll get, if I sum moments about B, I should be able to find the force GH. Is there another point where 2 forces cross? G. So if I do kind of extend the line of action of these forces, they do cross out here at some point G. That would be a great place too. So BG and GH pass through G, I can get BC. Now BC and GH are only in the x direction, so I don't probably want to sum forces in the x direction because I'd have to use both of those values to find BG. You could, and you should be successful, but in the exam, probably the safer bet would be to sum forces in the Y, because BG is the only thing with a Y component. So once you have that strategy in your head, now you can write any of those 3 equations in any order you like. Now this is very hard, and I've seen it more than once. Well, I've seen it many times. When I hand out the exam, half of you will start working problem 1 immediately. There's this need to binge or purge. You've been binging studying for I don't know how long. You now need to purge. So you won't even look at the problem. You won't even think about it. You just need to get something out on paper. You got to get it out. So don't do that. First of all, I'm going to talk about every problem for a couple of minutes. And if you're madly scribbling down something else, you're not listening to maybe some hints that I give you. That's one mistake. The second mistake is you need to think for about a minute. Right? Just develop a strategy before you plow ahead. It'll save you. Because that's the hard part, is deciding how to work the problem. The rest of it now is just mechanics. Apply the equations. Okay, so let's do that part. So I'm going to sum moments about B, because that's the first one you suggested. So now, let's see. BC and BG go through B, no moment. This 1 kip force at H passes through B, no moment. So I just have these 2 forces over here to account for, and the force GH. Now GH is going to create what kind of moment about B? Positive or negative? Positive. So there's the force in GH, and its moment arm is the height of the truss, which is 16 feet. Now, when I go over here to this combination of forces, they're on the same line of action. So they're going to have the same moment arm. In this case, the bay of the truss, which is 12 feet. One of them is going to create positive moment. One of them is going to create negative moment. You can do them both separately, or you could what? Sum these forces and do them as a composite, whichever one you like. Since I'm not getting a good feedback from you as you look at me on that, I'm not going to do it that way. I'm going to do it one at a time. So the 1/2 kip force creates positive or negative moment about B. Positive. So I've got 1/2 kip times 12. And then the 2 kip is negative, also 12. So now maybe you can see that that is the equivalent of what? If I add these two forces together, I get 1.5 up, which would create negative 1.5 kip times 12. And you can see those things are equivalent. So whichever way works for you. So what is the value of GH? I think it should be positive, but I have no idea what that number is. 24 divided by 16. What's 24 divided by 16?
4.5.
Is that what it is? Anybody else get that? Excellent. That seems reasonable. You know, if you got 1.5 million, right, Mr. Abney?
Yes.
Check your units. Now what? Let's sum moments again. This time we'll sum them about G. So out here about G, BG, GH create no moment, so I have force BC. Everybody else contributes. So starting with the force BC, does it create positive or negative moment about G? Negative. So I've got force BC, and what's its moment arm? The height of the truss? 16. Let's start with this force first. Does this one create positive or negative moment about G? Positive. So that's 1 kip. What's its moment arm? 12. Then I got my couple over here that I've dealt with before. So this time I'm going to say it's just 1.5 up. That creates negative, so I'll write 1.5. And what's the moment arm from G to A? 24. So what is the force BC? I think it's going to be negative, but you guys tell me.
Dr. Camp?
Yes?
Force GH, the 1.5 times 12, that's 18, and then you divide it by 16.
The one before?
Yeah, so it should be 1.125.
Oh, you're right. This should have been 18 divided by... I said 24. I just looked at this piece. Thank you. So it should be what, Mr. Gargas? 1.25? 1.25? 1.125. Thank you. Yeah, I messed up. So if you look at this piece right here, you can see that that's 18, and you divide it by 16. I said 24 divided by 16. And I was just looking at this last term here. I messed up. Thank you. I would not have gotten the right answer. Luckily, it doesn't filter down into the rest of my equation, so hopefully I'll get this one right. So what is this? This is negative 30. Now this one's 24 divided by 16, so this one should be 1.5, right? Mr. Gargas, I'm relying on you now, since you're the only one paying attention.
I don't know.
Oh. Anybody else?
Well, wait.
This is negative 36 plus 12 is 24. 24 divided by 16 is 1.5.
1.5.
There you go.
Where's that 1.5 coming from when you multiply?
That's my composite. I took the 2 and the 1 and added them together and got 1.5 up.
Okay. Okay, when you're summing your moments about G, why do you not use FBG
F,
in the Y direction in the X?
because FBG's line of action passes through G, creates no moment. Remember, FBG FBG exists anywhere along that line of action. Now, we can't do any more moment equations, but as we discussed previously, I can sum forces. So let's sum forces in the y direction. So I'm looking at my y components. I have this couple over here I've dealt with before, this guy, and then I want the horizontal component of this. And as we've looked before, this 12 to 16, if you divide by 4, you get a 3 to 4. So this is a 3, 4, 5 triangle, and the y component would be 4/5 of BG. And it is acting down, so I'll make that a negative. And then I've got 1 kip acting down, a half kip acting down, and then 2 kips acting up. So it looks like, what do I get here? Half, I don't know what, 0.625? All this over here ends up with a positive a half, right? So I should get a negative number. No, I should get a positive number. 0.625. Mr. Gargis? Oh, you're still behind? I like that. That looks pretty good to me. Any questions about this? Okay. I'll stop that.